Today our topic is chemical kinetics. What is chemical kinetics? Chemical kinetics actually deals with the speed of chemical reactions and the mechanism of chemical reactions. So what is chemical kinetics? Branch of chemistry which deals with the study of reaction rates and their mechanisms, called chemical kinetics. So in chemical kinetics, we have to discuss the rates of chemical reaction or speed of chemical reactions and the mechanism of reactions. You have an idea about mechanism of reactions last year in the chapter Basic Concepts in Organic Chemistry. We discussed the mechanism of chemical reactions. What is the rate of a chemical reaction? How will you measure the speed of a chemical reaction? You know, during a chemical reaction, reactants change to products. Reactants change to products. So at the beginning, when the reaction begins, there is only reactants. And as the reaction proceeds, what happens? Products form. The formation of product, gradually the formation of products will take place. That means the concentration of products increases with the reaction. As the time proceeds, the concentration of reactant increases, but the concentration of reactants decreases. So during a chemical reaction, what are the changes taking place? Decrease in concentration of reactants and increase in concentration of products. From this decrease in concentration of reactants or from the increase in concentration of products, we can find out rate of a chemical reaction. So rate of a chemical reaction is the rate of change of concentration of reactants or rate of change of concentration of products. So rate of a reaction is equal to rate of disappearance of reactants. That is equal to decrease in concentration of reactant divided by time taken. If R represent reactant, then rate of reaction can be represented as minus delta concentration of R by delta T. Here the negative sign represent decrease in concentration of reactants, which is equal to rate of appearance of product. That is increase in concentration of product divided by time taken for the change. That is equal to delta concentration of P divided by delta T. Here it is positive. The reason, there is an increase in concentration. So here, in the first equation, there is a negative sign. In the second equation, there is a positive sign. But during the calculations, you will understand both the values will be positive. Both the values will be positive and the same, equal. And the reason change in concentration is measured as final concentration minus initial concentration. In the case of reactants, concentration decreases. So the final concentration will be less than the initial concentration. So final concentration minus initial concentration will be a negative value. So minus will become positive. At the same time, in the case of product, the concentration increases. So the final value will be always greater than the initial value. So final value minus initial value will be positive. So rate of a reaction can be expressed as the rate of decrease in concentration of any one of the reactant or the rate of increase in concentration of any one of the product. Here, we consider the initial concentration and final concentration, and the time taken for the complete change. So change in concentration divided by time taken for the change will give you an average rate. An average rate, only an average rate. The reaction may not be proceeding in the same speed throughout. It will complete in different speeds. Initially, the speed will be more. And as the concentration of reactant decreases, the rate of the reaction also will decrease. But when we calculate the rate of the reaction, we'll get only the average rate. For example, when you go to school, suppose you require 30 minutes to reach in your school. And the distance between your school and home, suppose it is 10 kilometers. So what is the average speed of your journey? 10 kilometers in 30 minutes. So 10 by 30 kilometers per minute. 10 by 30 kilometers per minute. That is 0.33 kilometers per minute. That is your speed. 0.33 kilometers per minute. But you know, when you are starting from your home, sometimes you may walking. At that time, the speed will be less. When you are traveling in a bus, the speed will be more than 0.33 kilometers per minute. So, when you calculate the total time taken 30 minutes and the total distance 30 minutes, 10 kilometers, you are getting only an average speed. Similarly, in the case of chemical reactions, you will get only an average speed or average rate. Average rate depends upon the change in concentration of reactants or products and the time taken for the change to occur. We are not considering a particular instant or a particular second. The total time taken is considered. So if there is an average rate, it is very clear there will be a time to represent rate at a particular moment, and that time is known as instantaneous rate. So instantaneous rate is to express the rate at a particular moment of time. Rate at a particular moment of time. That is instantaneous rate. It is obtained when delta t tends to 0. When delta t approaches 0, the average rate will change to instantaneous rate. When delta t approaches 0, we can represent delta t as dt. Dt represents a very, very small time interval, maybe a fraction of a second. Such a small time interval, dt. So we can rewrite the equation to find out the rate as instantaneous rate is equal to minus d concentration of R divided by dt, where d concentration of R represent a small change in concentration of reactant for a time period dt, and that is equal to d concentration of P divided by dt. A very small change in concentration of product during the time interval dt. That is instantaneous rate. Instantaneous rate is equal to minus d concentration R divided by dt, which is equal to d concentration of P divided by dt. Or dt is a very small time interval, a fraction of a second. So I think it is enough for today. You have to read and understand it clearly, then only we can proceed to the next topic. Okay.